Hi everyone. Here is a video on an introduction to basic probability, and we're going to use the data that we had for our candy experiment in class. Um, but before we start anything, I'm going to start you with a rule. And what exactly is probability? Well, the probability of something happening, or in other words, the probability of an event, we'll call that event A, some event A, is always going to equal the number of ways we can get what we want. In other words, we call that successes out of the total number of possible ways something can happen, or outcomes. All right, so in statistical language, we write that as the probability of an event happening, say some event A, is equal to the number of successes over or divided by the number of total, keyword there being total possible outcomes. Longer line there, okay? So something very simple might be, for example, if you toss a coin, let's say we want to flip a quarter, okay? We might say, what is the possibility of flipping a head? Okay, so that means our event, or in this case A, would be flipping a head. All right, so the probability of tossing a coin and getting that head is equal to the number of successes. Well, let's think about it. We're going to flip a coin. How many ways can we get a head? Well, there's only one head on the coin. There's only one possible success, divided by the total possible outcomes. So when you flip a coin, how many different outcomes can you get? Well, you could get a head or you could get a tail, but that's it. You can't get ears or an elbow. You just either get a head or a tail. That's it. Those are the total possible outcomes, and there are two of them. And I'm using a very simple situation that I know most of you know the answer to. Um, most of you know the probability of flipping a head is a half, or if you did that on your calculator, you'd get a 0.5, or we could write it as a percent, 50%. Okay. So it's a 50-50 chance of tossing a head, 50% chance, a 0.5 chance, or 1/2 chance. Um, all right. So let's make our data a little more intricate. And I'm going to do that by pulling up the data that we had in class. Okay, so here's the table with the numbers of each type of candy that we had. So, for example, just analyzing the table a little bit here, this top row is the colors of our different candies, and this going down is the type of candies. So, for example, this 11 right here, we had 11 red M&Ms. There were 13 orange M&Ms, and so on. And this 72 down here in white, that total means there were 72 M&Ms. Going vertically through the columns, there were 11 red M&Ms, and down here there were 8 red Skittles, making a total of 19 red candies. So these numbers down here on the bottom row are your colors of your candies. So altogether we have 122 candies that were in our cup. So what is the probability of a green candy? Well, if the formula for the probability of an event is the number of ways we can get what we want out of the total possible outcomes, we'll go ahead and make a division line here. Well, sometimes it's best to start with the denominator. What are my total possible outcomes? In other words, how many candies were in my cup? Well, there were 122 candies in the cup, so there's 122. That's the total possible choices. If I stick my hand and pull out something, it's going to be one of those 122 candies. The numerator then is the number of successes we want. Well, a success for this event is getting a green candy. So I'm going to go to the green column. There are 18 green M&Ms and 7 green Skittles, making a total of 25 green candies. So we end up with a 25 over 122. which, if you do that on your calculator, you will end up with a 0.205, or in other words, approximately 21% of the time. 21% of the time, if you were to stick your hand in that cup and do it over and over and over again, 21% of the time you would draw a green candy. Okay, this is what we call a marginal probability. Marginal. Okay. And what that means is when you go to do it is you're looking at the margins. You took the 25 is in your margin here of totals out of your total possible outcomes. All right. Okay, let's try another one. In this one, let's find the probability of an orange M&M. Okay, this is what we call a conditional probability, or I'm sorry, apologies, a joint probability. Why is it joint? Because even though we're calling it an orange M&M, it's actually sort of two things happening in that we're talking about color and type of candy, whereas the last one was just strictly color, a green candy, any green candy. Now we're talking about a specific color and a specific type of candy. So going over here to our formula, our bottom number is again 122. That hasn't changed. We still have the total possible outcomes of 122 candies to choose from, except now we're just talking about the orange M&Ms. So we have 22 orange candies, but only 13 of them are M&Ms. So it's just this 13. There's only 13 successes. There's only 13 ways to get what we want of an orange M&M. Okay, so that is what we call a joint probability. So even though we have different names here, all these probabilities fundamentally have the same basic formula. Okay, what's the probability of this situation? What is the probability of getting a Skittle? Getting a Skittle, that's my probability, that's the question. Now this line here means given. Given, or in other words, this is what we call a conditional probability. In other words, we are told that what is to the right side of this line has already happened. What is the probability of getting a Skittle given the red candies? In other words, you're going to take all the red candies out of that cup of 122, all those red candies, put them in a different cup, and you're going to stick your hand in there and choose out a candy. All right, so now our bottom number is changing. We're no longer with a cup of everything in it. We only have the red candies in the cup. So I need to go to my red column here. I've got 11 M&Ms and 8 Skittles, giving me a total of 19 red candies. So now my 19 goes on the bottom because this is what I'm choosing from. So one way to think of this is when you've got conditional probability, this whatever this is to the right of the given sign goes into your denominator. Okay, the numerator is still what you want. What is the number of successes? And that's to the left of your slash here, your given line. So we still want to know what's the probability of a Skittle. So again, we have to look at how many successes, or in other words, how many Skittles do we have within the group that we're choosing from. So we're only looking at this column here. And of these 19 red candies, 8 of them are Skittles. 8 of them are successes for what we want. So this probability of a Skittle, getting a Skittle given the red candies, is 8 out of 19. And if you do that on your calculator, you get a 0.421, which is roughly 42%. Good. So now we've taken a look at conditional probability, joint probability, and marginal probability. So let's add another layer here. Okay. So this problem says, what is the probability of an M&M or a brown candy? So again, we've got all our candies in our cup. So our bottom number is back to being 122. Those are all the different candies we're going to choose from. But now we've got this word or. That means if we stick our hand and we pull out an M&M, that's a success. If we pull out a brown candy, that's a success. Okay, either one of them are success. So we actually have sort of two things happening here. So whenever you have the word or, you need to think this is what we call the addition rule. We have to think of the word, we're going to have to add something. Okay. Well, let's circle what's going on up here. What is the probability of an M&M? Well, look at how many M&Ms I have. I have all of these M&Ms. 11, 13, 12, 18, 10, and 8. All of these are M&Ms. In fact, I should pick a different color here. This is a little easier to see. Let's do a red here. Okay, so all of these are M&Ms. Okay. In fact, all 72 of them. Right? We can add them all up. So I can see that that total is 72. There are 72 successes that way. Okay. All right. Plus, what else are my successes? Well, all these brown candies are successes. So I have these brown candies here, the 8 M&Ms and the 10 Skittles. Okay. So that's another 18 successes. However, what you will notice is that this 8 right here, these brown M&Ms, actually got counted twice. You've got 8 in this 72, but that 8 is also included this in the 18. So this number 8 right here has actually been counted twice. So we have to subtract off one of them, just one of those 8s, because it got counted twice. So this is the addition principle. It is actually a marginal probability because we are dealing in the margins. We're applying the addition rule, and these events are what we call not mutually exclusive. In other words, if you were to draw a Venn diagram of M&Ms and a Venn diagram of brown candies, there would be this overlap. So over here would be your non-brown M&Ms, all the other colors, your orange M&Ms, your red M&Ms. Over here would be your brown non-M&Ms. These would be like your brown Skittles. Over here you'd have some brown Skittles. But these 8 right in here, those are your brown M&Ms, and that's why they get counted twice. They get counted once when you're adding up your M&Ms, and then they get counted again when you're adding in your brown candies. Okay, so that's why they needed to get subtracted off once, because they get counted twice. Okay, so if we do this math, remember to add your numerator up first. 72 plus 18 divided by, minus 8. Get the equal sign, then divide by 122, and you will get a probability of 0.672. Okay, about a 67% chance of getting M&M or brown candy. All right, let's try another one. Okay, what is the probability of a yellow candy, or, here's that word again, or, means we are going to apply the addition rule. What is the probability of a yellow candy or a blue candy? So we have two different things that can happen here as a success. Again, we are choosing from all the candies. The whole cup is full of all 122 candies. And we know we've got to add the two. What are our successes? The numerator are the successes. So we're going to have to add up our yellow candies and our blue candies and then subtract off any overlap. But look what happens here. When we look at our yellow candies, we're talking about this row here. I'm going to take another color here. We're talking about this row right here. There are 12 M&M, yellow M&Ms, and there are 16 yellow Skittles right here, giving me a total of 28 yellow candies. I'm going to write the 28 right here. Plus the blue candies. Well, if I go over here, here are my blue candies. There are 10 blue M&Ms and there are 0 Skittles, blue Skittles. So that gives me a total of 10 blue candies. So those are also successes, so they go in the numerator. And normally I would subtract off the overlap, but look at these. You can't have a candy that is both yellow and blue. Unlike the last problem where you could have a candy that is both an M&M and brown, there's no overlap here. They're both columns. So these are what we call mutually exclusive. If I go back to those Venn diagrams, They would not intersect at all. There's no candies that are both yellow. Here are your yellow candies, your M&Ms and your Skittles, and here are your blue candies. Well, just M&Ms in this case. And there's no overlap, nothing there. Okay, so these are what we call mutually exclusive events. Mutually exclusive. It's just the probability of the first plus the probability of the second, which equals, again, you can do this on your calculator, 38 over 122. And if you do that on your calculator, you are going to get 0.311. So you have about a 31% chance of getting either a yellow candy or a blue candy if you are reaching into all the candies. Okay, let's try another one. Okay, here's where things start getting a little more interesting. We have pretty much looked at every different type of single event where you're just pulling out one candy. But what happens now if we have multiple events? Meaning I'm going to reach in the bag, take out one candy, and then I'm going to reach in that bag again and take out another candy. All right? So we actually have two events here. What I want you to think of it as we are going to get we're going to draw a yellow candy. I'm just going to use the word Y for yellow. And then we're going to, actually, let me undo that. We're actually going to then draw another candy. What is the probability of getting two yellow candies? So now we've got two events happening. Two events happening. So let's break it up into parts. Well, let's just start with the probability of the first one being yellow. Well, we know the formula. Total possible outcomes, which is 122. 122 on the bottom. And how many do I have on the top? Well, how many of these 122 candies, how many of them are yellow? This is a marginal probability because it doesn't specify M&Ms or Skittles. So there's 12 M&Ms that are yellow and 16 Skittles, giving me a total of 28 yellow candies. So I'm going to go ahead and write that 28 right here. Okay. And what is the probability that the second one is also yellow? Okay, well, I'm just going to put that right here. The rule, that same formula applies again. I need to reach into my cup a second time and pull out a second candy. All right. All right. Well, so let's start with the denominator. How many candies am I choosing from? Well, remember, we've just picked one candy over here. So now there are only 121 candies left in that cup. Okay? When we go to the numerator, because what's happened, we have chosen out one candy. So we've got one less in there. We also have one less yellow candy because that was the one we picked. It was right here. It was one of those. If the first one is yellow, what's the probability the second one is also yellow? Well, when I reach in to pull out a candy, there's only 27 of them that are left as yellow because one of them's already been taken out. All right. What do we do with these two probabilities? I want you to think of this almost like an and. It's like getting a yellow and another yellow. So whenever we have an and, we are going to multiply those probabilities. We're going to multiply those probabilities. In the word or, we add. When we have and, we multiply. Okay, so if you do this on your calculator, you are going to end up with 0.051. So our probabilities really start to go down when you're looking at the probability of multiple events. And this is also what we call, this is what we call dependent events. Dependent. Okay, dependence just means that the probability of the second thing happening, depends on what happened the first time. So pulling a second yellow candy is dependent on first pulling a yellow one, on pulling the first one. And we'll talk about independent events in a minute. Okay. Okay, here's a challenging one. Now let's see what's going on here. This time we are asking, what is the probability of drawing a green candy given that, remember this word given, so we're talking, we've got a conditional probability here, conditional. Given that it's a Skittle, And so we're talking about two events here, a yellow candy given that it's an M&M. So we've got two conditional situations, and we've got the multiplication rule because we are drawing two candies. We've got two events. So I wrote that again here, just in a little more simplistic statistical language. What is the probability of a green M&M given that it's a Skittle, and what's the probability of a yellow M&M given it, yellow candy given it's an M&M? Okay, so let's do this. Let's start with the probabilities of each one. So we'll break it up. And this time I've got two probabilities, two events. I know I'm going to have to multiply them. And I'm going to start with the denominators. Okay, so this time things are conditional. So this first one is telling me that I'm choosing from the Skittles. So what I want you to imagine is that you are taking all your 122 candies and you're putting them into two different cups. You're putting your 72 M&Ms into one cup, and you're putting your 50 Skittles into the other cup. Okay? Now, the first event, you're going to reach into that M&M cup and you're going to pull out something. All right, so now what are you choosing from? Now your bottom number here is 72. You're choosing from 72. I'm sorry, we're choosing from the Skittles first. Okay, so let's erase that. So we got the Skittles are here. We're going to put our hand into the Skittles first. We're going to take it out. What is the probability that we get a green candy or a green Skittle? Well, there's 50 Skittles in that cup. And of those 50 Skittles, here are my green, of these 50 Skittles here, 7 of them are green. So I've got a 7 out of 50 chance of getting a green candy when I go reach into those Skittles. Okay, so then I've got my first candy. Now I'm going to go to my second event. Now look at this. These events are what we call independent because one does not affect the other. They're two separate cups. Unlike last time, which we were reaching into the same cup, so the denominator was changing, affecting your probabilities. This is not the case. Now you're going up here to the M&M cup, and you're reaching in there. So your second event, you're reaching out of 72 M&Ms, and of those 72, how many are yellow? Looks like 12 of the from the M&Ms are yellow, so we've got a 12 here. So again, multiplication rule, conditional, multiple things happening here, independent events. If you work this out on your calculator, you're going to get 0.023, so barely a 2% chance. Okay, and that's because you have multiple things happening. Both things have to happen. And so as you add more events, the lower your probabilities will become. All right, so hopefully you're starting to get the hang of this. Okay, we're going to add one more situation here, which we'll talk much more about. But this is just a little introduction to what we call combinations. A combination. Okay, because this is one where, what if we ask, what is the probability of drawing an M&M and a Skittle? So in other words, we've got two events here. We know we're going to have to multiply them. But I'm going to rewrite this in statistical language. And how can we get these to figure out what we need to do? So when we write it in this form, we're talking about the first thing happening in the first spot. So in other words, if I write this as an M&M followed by a Skittle, that means I first draw an M&M and then I draw a Skittle. Again, this is two events. Even though you're taking them out at the same time, what's really happening is first you're drawing one candy and then you're drawing another candy. So one way you can get an M&M and a Skittle is to put your hand in the cup, first pull out an M&M and then pull out a Skittle. Or you could also reach in, pull out a Skittle, and then get an M&M, and that would also be a success. So what's really going on here is we have an and an or. All right, so we want to find the probability of getting an M&M and a Skittle, or a Skittle and an M&M. I know in the end you still got one M&M and one Skittle, but probability does take into account the order in which things happen. So let's go ahead and do this then. let's start with this first one right here, which is a dependent event. And we've got this comma, which is an and, so we know we've got multiplication. So we've got to figure out the probability of first getting an M&M and then getting a Skittle. All right, so let's start here. What's the probability that the very first candy is an M&M? Well, basic marginal, we're talking about marginal event, and we're talking about, so we got 122 candies right here. That's my denominator. I'm pulling from the whole cup. And I want to know the probability the first one's an M&M. Well, how many M&Ms do I have in the cup? I have 72 M&Ms in the cup, so there's 72 right here. Okay. Then, if I've picked that M&M, what's the probability that the second candy I pick is a Skittle? Well, I've now picked one candy, so there's only 121 candies left in there. Of those 121 candies, how many of them are Skittles? How many successes? We have 50 Skittles in that cup that are 50 Skittles in the cup of 121 candies left. All right, so that's the first, that's this right here. Okay, now let me take another color here and we'll do, let's do this one here. I'm going to add to that, what is the probability of getting a Skittle and then an M&M? So again, I've got an and, which means I've got a multiplication issue problem. And we're starting over again because now we've got the, this is the other possibility that can happen. So I can reach into that candy, into that cup with 122 candies. And the first one this time, though, would be a Skittle. And of those 122, there's 50 Skittles. Then when I reach in a second time, now there's only 121 candies left. But of those 121, 72 of them are M&Ms. So you want to do this on your calculator, and then you want to do this on your calculator, and then add those results. And what you will get is 0.488. And we can go over that on, or roughly 49% chance. We can go over that in class if you're having trouble getting that on your calculator. Okay, so this is this problem is just kind of putting everything together. Oops, got my. All right, we're going to look at two more situations, and then call it a day. Okay, I just want to touch on these two types of problems as well. What is the probability of drawing a blue candy given that you're choosing from the Skittles? So in other words, this is conditional probability. We want the probability of blue candy given a Skittle. Okay. Let's take a look at that. All right, well, given a Skittle, so we know that goes at the bottom. How many Skittles do I have? I have 50 Skittles here, so that's my bottom number. And of those 50 Skittles, how many are blue? Well, look right here. 0. There are no blue candies in there. So I have to put a 0 here. All right. And 0 divided by 50 is 0. There's a 0% chance of happening. That means it is impossible. It is impossible to draw a blue candy out of a cup of Skittles because there are no blue Skittles. Okay. So the lowest probability you can ever have is a 0% probability, just the number 0. Can't happen. All right, let's take a look at the flip side of that. What is the probability, I'm going to rewrite this as statistical, of an M&M given that it's a blue candy? Okay, what is the probability of an M&M given that it's a blue candy? So now my blue candies go on the bottom. How many blue candies do I have? Well, here are my blue candies here, and I have 10 of them. I have 10 blue candies. And of those 10 candies, my M's, what's the probability of that M? Of those 10 candies, how many of them are M&Ms? What is the probability of pulling out an M&M if I have a cup full of blue candies? Well, look at that. All 10 of them. If you've got a cup of blue candies, they're all M&Ms because there are no blue Skittles. So if you reach in and pull one out, what's the probability it is a M&M? Well, it has to happen. And that is a probability of 1 or 100%. That means it must happen. Okay? So it's very important to remember that with probability, the probability of an event, the probability of any event will always be less than or equal to 1 or greater than and or equal to 0. It's always going to be a decimal or a percentage. You can't have a probability of something happening of 200% or a negative number. It will always lie in this range. Okay, so if you end up doing your work and you end up with some probability of 3.72, you've made a mistake. You need to check that, okay, because that can never happen. All right. Oops. Okay, so to summarize, these are the things that we've looked at in this video. We have talked about the different types of probabilities, marginal, joint, or conditional. And then within those three, you can have different things happening. You can have multiple events, which can be mutually exclusive, independent, or dependent. And finally, what you really want to remember are the two rules. If you have the word or, that usually means we're going to apply the addition rule. And if you have the word and, it means you're going to apply the multiplication rule. So if at any time you're struggling with what to do, come back and watch this video, and it covers all these different types of basic